In this video, we're going to deal with handling discontinuity initial value problem. So, the first question that we're going to deal with is find a particular solution to the equation dy over dx equals 2x minus secant squared x, whose graph passes through the point 0, 3. So the point that passes through is 0, 3. So the antiderivative of dy over dx is y equals x squared minus tangent x plus c. So now we have to solve this. So we're going to get 3 equals 0 squared minus tangent of 0 plus c. Now some of you guys are like, what's tangent of 0? Well, that's sine over cosine. Sine of 0 is 0. Cosine of 0 is 1. So it's 0 over 1, which happens to be just 0. So let me just prove it right here. Sine over 0, cosine over 0 equals 0 over 1. So that's 0. That's what tangent of 0 is. So now c equals 3. So the initial condition is y equals x squared minus tan x. The antiderivative is equal to y equals x squared minus tan x plus 3. Now, if you look over here, you're going to have domain issues on tangent of x. In Algebra 2, you were hopefully taught that you cannot divide by 0. So where does cosine equal 0? So here's cosine of x. Cosine of x is going to look like this graph over here. And this is pi over 2. That's pi. And this is going to be 3 pi over 2, and so on. So when you actually continue, and it keeps going on at k pi intervals, I'm sorry, these are the same height. So now when you actually check this, the interval that you're on, 0, 3, happens to be in the middle of these 2 points. If it was in between these, then that would be your domain, pi over 2 to 3 pi over 2. In this case, it's negative pi over 2 to pi over 2. So you have to state that, and you have to say, in the domain, of negative pi over 2, which is less than x, which is less than pi over 2. So this is where your domain exists. In this is the function, and that's the domain where it exists. So here's another function. dy over dx equals 5 secant squared x minus 3/2 root x, and y equals 7 when x equals 0. So the antiderivative of dy over dx is y. The antiderivative of 5 secant squared x is 5 tan x, tangent. And now this might be easier if we write it as negative 3/2 x to the 1/2. So when we add 1, we're going to get 3/2. And then you're going to have to divide. Let me do it over here. So now you're going to get minus 3/2 x to the 1/2 plus 1, which is 3/2, and now we have to divide by 3/2. But remember, when you divide, you actually have to multiply by the reciprocal plus c. So now we get y equals 5 tangent x, and now we're just going to get minus x to the 3/2 plus c. Now let's plug in our initial condition. So we're going to get 7 equals, we already proved tangent of 0 is 0 minus 0 plus c. So c is going to equal 7. So our function is going to be y equals 5 tangent of x minus x to the 3 halves plus 7. Now, there's going to be two parts where this is going to have a domain issue. Where cosine equals 0 and when x equals 0. Actually, yeah, you can have a negative inside a root. So instead of being negative pi over 2 to pi over 2, it's now going to be cut in half because this actually makes your domain start at 0. So your domain is going to be in the interval from 0 between x and pi over 2.